Okay, we're now going to consider a skydiver, somebody jumping from an aeroplane. At first, he jumps out of the aeroplane, there's no air resistance. There is a big force acting downwards due to gravity, his weight pulling him down, so he starts to speed up, he starts to accelerate downwards. After some time, the air resistance takes effect. The air is pushing against him and trying to slow him down, so he doesn't accelerate at the same rate. Eventually, that air resistance will balance out, you can see the arrows being the same size, balance the force out, so he'll reach a steady speed, and this is called a terminal velocity. He will not get any faster or any slower. He could get faster if he reduced the air resistance by tucking in his arms. The other thing he can do is obviously pull his parachute, and when he does his parachute, you see the size of this arrow is massive because the surface area of the parachute is big, so it gets a lot of air resistance. This slows him right down. You can see the force upwards is bigger than downwards, so it slows him right down until he reaches another terminal velocity. At this point, he's going quite slow, and he should be going slow enough, safe enough to land. So here's a graph of his motion. If you plot velocity against time, when he first jumps out the plane, he's not traveling at all. He quickly increases speed, a steady acceleration there shown by a straight line, and eventually he will reach what's called a terminal velocity. So the speed increases and he reaches terminal velocity, and then when he pulls his parachute open, you can see he slows right down and he ends up at a slower terminal velocity, which is slow enough to let him land on the ground. And there he lands on the ground quite safely without any injury.